All right, so at this point, you kind of got the idea of planes. You're fairly solid with lines, right? You did some intersection stuff with lines. All right, well, let's just throw another wrench in it because obviously, if we can find the intersection of lines, we can find the intersection of a line and a plane. So that's the next thing that we're going to start looking at is, okay, well, I already know how to find that intersection of lines. I learned how to do two-dimensional lines back in like Algebra 1. Then I learned how to do three-dimensional lines with vectors like 2 days ago. And now I'm going to do lines and planes since I know a little bit more about planes. So first, I'm going to write the parametric equations for the line. Okay, so I'm going to go A and B. So in order to write the line, I need a starting point and I need a direction. So for the direction, I'm going to find vector AB, which is going to be equal to 2 minus negative 1, 0 minus 2, and negative 3 minus 3. So the x minus x, y minus y, z minus z, the final minus initial, it's always a change. All right, which gives me then 3, negative 2, negative 6. So now that I have a direction vector, I can write an equation for line 1. So I'm just going to write line 1 equals, and I can put in either of these 2 points. If you like the 0, you can put the 0 in, 2, 0, negative 3. I'm just going to put in A because I feel like it. That's what you got to do. And then we're going to add on the direction vector, which was 3, negative 2, negative 6, times your parameter, whatever you want your parameter to be. Okay, so there I've got line, and this is in vector form, right? So vector form is easy to get. It's easy then to put in parameter form because line 1 is equal to x, y, z in 3 dimensions. And so now I can say that x equals negative 1 plus 3 lambda. I was thinking 3 and already saying 3 and already writing lambda. Y equals 2 plus negative 2 lambda. And then z or z is equal to 3 minus 6 lambda. So I've now got it in parametric form. But the question isn't find it in parametric form. Well, that's the first part, which I've done. Now, I was kind and asked you to do that because that's what you need in order to be able to find the point where it intersects the plane. The problem with having a vector equation in a plane is that you have x, y, and z. That's 3 variables. I'd rather not deal with 3 variables. So what we do, strangely enough, is we introduce a 4th variable, which is lambda. And lambda is now a 4th variable, but that's okay because I can write x, y, and z all in terms of that same variable, that same lambda. And what that means is I can now substitute these into my equation for the plane. And so I'll go ahead and put x in for x. So this becomes negative 1 plus 3 lambda minus 2 times y, and y was 2 minus 2 lambda, plus 3 times, oops, parentheses went the wrong way, 3 times z, which was 3 minus 6 lambda, and I just right there, and that will be equal to, oh, I'm out of space, oh, just kidding, I got space, equals 26, and so from there I can now solve for lambda. And so I'm going to have negative 1 plus 3 lambda minus 4 plus 4 lambda from the distribution of the negative 2 there. And then I'm going to have plus 9 minus 18 lambda from the distribution of the 3 equals 26. And then I will add up all the constants. So negative 1 and negative 4 is negative 5 plus 9 is negative, just kidding, positive 4. I can really do math. 3 lambda plus 4 lambda is 7 lambda minus 18 would be minus 11 lambda equals 26. Of course, I subtract the 4. I get negative 11 lambda equals 22. And of course, because I wanted to, I made this work out really nicely, which means I get lambda equals negative 2. Now, don't expect that on an IB exam. They can give you a lambda that will be a decimal or a fraction or whatever the freaking heck they want it to look like. But we got lambda equals negative 2. But that is not the end of the question because the question asks for the point. It asks for the point where it intersects the plane. So now that I've got lambda equals negative 2, I need to find out where in the world that point is. So in order to find that point, I'm going to put lambda back into my equation here, or you can put it into your parametric equations. Doesn't really matter. They're obviously the same thing. They just look a little bit different. And so I'm going to go ahead and put it in. So x is going to equal 3 times negative 2. So that will be negative 1 minus 6 will be negative 7. I'll put negative 2 in for this lambda. So that will be 2 plus 4, which will be 6. And I'll put negative 2 in for that lambda, which will be 3 plus 12 is 15. So therefore, the point where it intersects is not a vector. It is negative 7, 6, 15. And that is the answer to the next question.